Hello, everybody. We're here today to talk about Desmos.com. This is a website that I have used quite a bit in my classrooms, in my high school math classrooms. But there's a new feature, to me at least, that I have not explored. And so we'll take time to look at that today, as well as the main part of Desmos that I have used at least, the graphing utility. That allows you to both visually display mathematical equations as well as do some discovery learning as well. This is targeted specifically for the students. This is really a great way for them to discover how lines interact with one another, linear and nonlinear functions behave, especially as things are changing, and then also to, just to display visually graphing information to use as a predictive model, or, there's all kinds of different things you can do with that. So that's not really the highlight, it's the program itself. So let's talk about this. We'll start graphing right out of the gate. While that's loading, I'll talk about the ISTE standards that I chose to match up. They both are in the student section this time. And the first one I've chosen is the student 6C, talking specifically about creating visualizations and models using a variety of digital objects. So in this case, not quite a variety, we're using a graphing utility, but we're creating these visualizations of these mathematical models. And that is quite beneficial if you know what to do with them. So that's part of the challenge as well, is communicating not only how to get them visually represented, but then what are we looking at? That's what they pay me for, I guess. The other one I chose is 5A, so let's go up and look at that one. This one deals more specifically with fostering independent, what did I choose here? Let's see. Oh, no, excuse me. Oh, no, I'm looking at the wrong one. Let's try that again. 3D is what we're looking at. There we go. Now we are definitely creating real-world problems and exploring how to break these problems down and developing new ideas in how to go about solving them using, a lot of times, predictive modeling. When you're graphing these types of math equations. All right, so let's take a look at the program itself. Again, the audience is the students. These guys are the ones that drive these assignments. I usually show them how to use Desmos and then kind of cut them loose and let them do their own thing. I'll reference an assignment that I talked about in a previous assignment. I can't remember which one it was now off the top of my head, but we have a major project in our Algebra 2 classes at the end of the year where they create these environments, these scenes, using equations, conic sections, linear equations, and then they place boundaries on them to create circles and line segments and things like that, and they create these wonderful pictures. I'll see if before the video, I'll see if I can pull one up here. Anyway, so here is our XY table. You can use your scroll on your mouse or these buttons up here to zoom in and zoom out. Pretty standard graph where you are incrementing 1 unit per section, but you can change that at your whim, of course. Here it is by tens. You can zoom all the way out to where it's by hundreds of thousands, and kids are always, that's like the most intriguing thing to them when I first show this to them. Anyway, when it comes to graphing a line, we can graph just a standard solution. Okay, x is equal to 5. So if we have something like x minus 3 equals 11, okay, then we can, where's the answer? Wait a minute. Isn't it supposed to be 8? I don't know why it's not showing me, 14. Oh my gosh. All right, I'm embarrassed. 14 minus 3, of course. So then you can discover that the relationship between the two-dimensional graph and the number line itself does exist with a vertical line there where x is equal to 14. If we wanted to throw a y in the mix, now our line shifts and changes. Okay, we can talk about the relationship between the intercepts. We can talk about the slope of the line, all this different stuff. So let's say I'm bored with this line. I want another one. We just click below. All right, let's throw this one into a specific form. Y equals ax minus 4. All right, where a is a slider. This is a very cool feature because a in this case is going to be representing our slope. So we can see what a positive 1 slope looks like. If we want to jack it up to 2 here, it's delicate. Now it's twice as steep. If we want to break it down to 0, we can see what it does. And then when we go the other way into negative, we can see what it does. I use this slider feature quite a bit, both with linear equations as well as the quadratic functions that we talk about in Algebra 1, because we can get really narrow, or we can point up or down based on what some of these coefficients are. So it's very, very helpful to discover how these lines and parabolas and such, how we can manipulate them just by switching specific numbers. All right, so let's talk a little bit more. We got some features here where we can turn lines on and off. If you hold that down, we can actually turn them into dashed lines. We can change their color. If red offends you, you can make it green or blue or black. If we want to, we can use these buttons down here, which allow us to turn these things into inequalities or use quadratics. Please ignore the children in the background, as they have forgotten that I am doing homework today, evidently. Anyway, so yeah, when we turn it into an inequality, we can shade that region. We can do, let's see, if we want to go ahead and turn that into a parabola, there you go. And our slider, there's another example of how our slider will make it do funky things. Pretty cool, I think, anyway, but I'm a math nerd, so that makes sense. What I also kind of want to talk about, let's go back to our original page, and this is all, so everything we've talked about so far is pretty, I'm pretty comfortable with. I've seen quite a bit, but what I want to talk about are these activities and learning models here. Here is some, oh yes, I'm so glad we found this, the creative art. All right, here is some of the things that, that I ask my students to do. We do use these as suggestions, but this is what theirs looks like. By the time it's all said and done, it's really remarkable how they get into finding all of these various equations and the boundaries in order to shade or in order to make these odd curves and things like that. It's really very impressive, and even students that that struggle through the course of the year find a way to manipulate these things to create something amazing, and it's quite a common thing. Anyway, there's all kinds of different things that you can look at through here. Classroom activities. This is the thing that I have not yet fully discovered. I believe you can assign assignments to groups of kids and things like that. And there's you can search for the activity. There's countless things. Let's just take a moment and say we want to work with slope intercept. All right, that's something we just got done working on. Line of best fit, great example. Okay, we can get in there and see these activities and see them from a student's perspective and things like that. You create a class code, and the students get in there and they're faced with all these different possibilities. So very powerful, a very useful tool in any math topic. This really starts in the mid grades, I'd say fourth or fifth grade, when you're talking about number lines and inequalities and things like that. Highly recommended. Desmos.com.